So in this video, I'll be solving another midterm 2 for Math 2B. This was given back in fall of 2018 by one of the professors at UCI, okay? So let's dive right in. Once again, I'll leave it up to you to check whether the content is matching what you're currently learning in Math 2B. So we're asked to evaluate integrals first. First one is sine cubed x dx. This is easy because we know when there's an odd power of sine or cosine, that's the easy case, because we can just save a factor of the sine or cosine. Sine x dx. So we saved one factor. You can rewrite it like this. Okay? We want to do that because now we can change the sine squared using the identity 1 equals to sine squared plus cosine squared. So 1 minus cosine squared is equal to sine squared. Okay? So we can rewrite it like this. And we want to do that because now we can let u be cosine x. Du is minus sine x dx. So we can substitute the integral as 1 minus u squared minus du. Okay? And now this is simply just the power rule, so it'll be u minus third u cubed plus c. Now we back substitute u, so that's cosine x minus cosine cubed x over 3 plus c. So that's your answer right there. Okay, you can of course distribute the minus sign, so it'll be this term minus cosine x plus c. Okay? Next one B, we have x minus 7, x squared minus 2x minus 3 dx. Oh, there we go. Okay, so how do we solve this? This one looks like partial fractions, so can we break it out into partial fractions? Let's factor to the bottom. That'll be x minus 3, x plus 1. Okay, so we break it out into partial fractions. It'll be a over x minus 3 plus b over x plus 1. Okay? Multiply both sides by this denominator, so we'll get x minus 7, because that would go away, is a times x plus 1 plus b times x minus 3. We got that. Okay? Now we want to solve for a and b. The quick way to do it here, we plug in x is minus 1, because this guy would go away. Then we're left with minus 4b is equal to, what's this side? Minus 8. So b is equal to 2. We plug in x is equal to 3 because this guy would go away. We get 4a is equal to minus 4. Okay, so a is equal to minus 1. So we found our partial fractions. We can rewrite the integral as we just plug in minus 1 over x minus 3 plus 2 over x plus 1 by dx. Okay? That was the hard part. This is the easy part now. These are just logs. So minus ln x minus 3 plus 2 ln x plus 1 plus c. That's our answer. Okay? Good. So we solved 2 problems already in less than 4 minutes. Oh. Okay. Let's move on. Now we have 1c. We have this integral from 3 to 3 root 2 x over square root of x squared minus 9 dx. Okay. This one, it looks like a trig sub, but the other clue that I see right away is if we let u be x squared minus 9, du would be 2x dx. We have some signature of it, x dx, so we can probably do a substitution also. So this one you can probably solve multiple ways. So I'll solve it one way fully and then I'll set up the other way. I see that the key does it with trig sub. I feel like that's slower, so I'm just going to do it u sub. I'm showing you the quicker way, probably. So if we let u, we said be x squared minus 9. Du is just 2x dx. Okay? So we can rewrite the integral as, well, we have to change the limits of integration. Let's do that afterward. We have x dx over here, which is equal to du over 2, x dx. That's du over 2, so can write it like that. This x squared minus 9, we say square root of u. Okay? This we can, we've got our limits of integration. Let's do that now. We plug in x as 3 over here in this definition of u. That'll be 3 squared minus 9. 9 minus 9, 0. 3 root 2 into here. That'll be 9 times 2, which is 18. 18 minus 9, that would be 9. Okay, those are limits of integration. Okay, so we can rewrite it as half integral from 0 to 9, u to the minus half du. Same thing. This is simple power rule. That'll be 2u to the half power. Evaluate from 0 to 9. These would cancel. So by fundamental theorem of calculus, we're left with 9 to the half power minus 0 to the half power. 9 to the half power is just square root of 9, that is 3. 0 to the half power, that's 0. So we have our answer right there. Pretty quick. In my opinion, slower way is we can do trig sub also. We would set up a triangle, well, at least how I would do it. We have a something squared minus something squared, so we know that x is the hypotenuse. 3 is one of the sides. We could put it either way. Let's do it like that. And square root of x squared minus 9 would be the other side. Okay? We know that secant theta is x over 3, so 3 secant theta is equal to x. That would be your substitution. Okay? And then 3 secant theta tangent theta d theta would be dx. Okay? And then we can also sub in the square root term. We know that tangent theta is the square root term over 3, so 3 tangent theta is that square root term, okay? So we can sub everything in its integrand in terms of theta, and then don't forget your limits of integration, so let me just do it. We can also solve it as, so we said x dx, so we have x and dx here. It'll be 3 secant theta, and then 3 secant theta, tangent theta, d theta, over square root term is just 3 tangent theta. Limits of integration, we plug in x as 3 into the definition here. We get secant theta is 1, or cosine theta is 1, the inverse, right? So where is the cosine 1? That's at 0. Similarly, 3 root 2, we plug in there. So where is secant theta equal to root 2? Or cosine theta is 1 over root 2. We know that that one is pi over 4. So this would be your integral that you solve. Okay, we know that this, so you'll be left with 3 secant squared. The integral of secant squared is tangent. So you get same answer afterward, okay? So that's how we do that. This showed you 2 ways to do it. And in my opinion, the u sub was easier, okay? 1D, looks like a more conceptual question. It says if f is a function such that f of 0 is equal to 2, f prime of 2 is equal to 3, sorry, f of 2 is equal to 3, and f prime of 2 is equal to 4, then what is the value of integral from 0 to 2 of x f double prime x dx. So we asked this to solve this guy. Okay? This should look like integration by parts, but also just a test taking strategy. They probably wanted to test you on each of the techniques. We haven't done it yet, so that highly likely that is a candidate to use that to solve. I cannot speak right now. Okay, but this should look like integration by parts. So that's the hint right there. Okay. So integration by parts. How do we say u? How do we say dv? Remember, we like to reduce this x. So likely u would be x. So du can be dx. So the x would go away. dv is whatever is remaining. So f double prime x dx. So v would be simply f prime x. Okay. So if this, let's say, is equal to I, then I is equal to uv minus v du. X f prime of x, evaluate this from 0 to 2, minus integral of v du, so that's just f prime x dx from 0 to 2. Okay? So that's simply x f prime x minus f of x, evaluate this whole guy from 0 to 2. Okay? So we would get 2 f prime of 2 minus f of 2 minus, in parentheses, 0 times f prime of 0 minus f of 0. Okay? So this is simply just 2 times f prime of 2, we are given as 4, minus f of 2, we're given as 3, minus 0 times whatever is 0, f of 0, we were given as 2. We would have another minus sign because of here. Don't forget that. Okay? So we have 8 minus 3 plus 2, which is 7. That's our answer. Okay, so not bad at all. Let's move on to improper integrals. Okay. So we're asked to find if this converges or diverges, and if it converges, to what value does it converge to? And if it diverges, does it go to positive infinity, negative infinity, or neither? Okay? Why is this improper? Because it'll be the limit as t goes to 1 from the right, and go from t to 2, 1 over x minus 1 dx, okay? So how do we solve this? This is simple, that's just a log. It'll be log x minus 1, evaluate from t to 2. So fundamental theorem of calculus, we would get ln of 2 minus 1 minus ln of t minus 1. Okay? ln of 2 minus 1 is ln of 1. ln of 1 is just 0. That goes away. Limit as t goes to 1 from the right of this guy. How does natural log look? Well, this is natural log shifted by 1, and this is t. So if this is 1, then natural log will look like this. Okay? So as you approach this guy from 1 from the right to 1 from the right, then that goes to minus infinity. We have another minus sign, so this would go to positive infinity. Okay? That's how we do that one. 2b. So we're asked for what values of p does this converge? 1 to infinity of 1 over ln of x to the 2p minus 5, and then there's another x on the bottom, dx. Okay, converge. Okay, so how do we do this? Well, might help us to start solving this guy. If we can see a quite obvious substitution. We let u be ln x, du is 1 over x times dx. So we have that signature right there, so we want to make that substitution. We'll worry about limits of integration after. That would be 1 over u to the 2p minus 5 power du. Okay, limits of integration, we plug into the definition here. When x is 1, u is ln of 1, which is 0. When x is infinity, u is ln of infinity, which is also infinity. Oh, actually, I wrote the problem wrong. This was e. Okay, so this would be 1, because ln of e is just 1. Okay. Okay, so how do we proceed from here? Well, this should look familiar because we know that integral from 1 to infinity, 1 over x, dx, this guy diverges. We also know that when you go from 1 to infinity, 1 over x squared dx, this converges. Okay? And actually, everything bigger than 1, so in between 1 and 2, as long as it's bigger than 1, it actually converges too. So we know that 2p minus 5 has to be greater than 1. Cannot be 1, so no equal sign. Has to be greater than 1. So 2p is greater than 6, or p is greater than 3. That's our answer. Okay? So you should remember that 1 over x dx diverges any degree bigger than 1 for this x. For example, x squared, that works. That converges, okay? So that's how we solve this problem. Okay, next. We want to see if these sequences converge or diverge, okay? And of course, if it converges, what does it converge to? If it diverges, does it go to positive infinity, negative infinity, or neither, okay? So 3a, we have a sub n is 1 plus 2 over n to n squared, okay? This, I don't know if I saw this in another video, this looks very familiar, but this should look familiar to the definition of E. Okay, so that might be a clue for later or whatnot, but how do we solve limit as n goes to infinity of a sub n? Okay, because it's n to some n power, we have to use logarithmic differentiation. Logarithmic, not logarithmic differentiation, we're not differentiating here. We can take the log of both sides, so natural log of a sub n is equal to natural log of 1, not absolute value, just regular parentheses, 1 plus 2 to the n squared, which we can pull the exponent out by properties of logs. Okay. So limit as n goes to infinity of natural log of a sub n is equal to limit as n goes to infinity of n squared ln 1 plus 2 over n, okay? We can rewrite this as limit as n goes to infinity, natural log 1 plus 2 over n over 1 over n squared. We want to do that because did I do this right? Let me double check my work. If I do this, yeah, because as n goes to infinity, yeah, this would be 0 over 0, indeterminate, because ln of 1 plus 2 over infinity, 2 over infinity is 0, so it'll be ln of 1, which is 0, over the bottom would also be 0, because 1 over infinity is 0. So 0 over 0, indeterminate. So we can use L'Hopital's rule. What does that say? We can take the derivative of the top, which is just 1 over 1 plus 2 over n, times derivative of the inside, which would be 2n to the minus 2 power. That'll be minus 2, because this is 2n to the minus 1, so we do the power rule, that'll be minus 1 times 2 times n to the minus 2. It should be like that. Over, this would be n to the minus 2, so that's minus 2, n to the minus 3 power. Okay? So we can simplify to infinity. This minus 2 and this minus 2 would cancel. Okay? How about this? Remember properties of exponents? This is n to the minus 2 minus 3. So that would just be an n on the top. So it'll just be n over 1 plus 2 over n. Okay? So what happens here? As n goes to infinity, this guy would go to 0, but this guy would go to infinity. So it'll be infinity over 1 plus 0. So this would be infinity, positive infinity. Okay? So we solved this. We're not done yet because this was the limit as n goes to infinity of natural log of a sub n. Okay? So this guy is just e to the, we just exponentiate this answer. E to infinity, which is also infinity. So it diverges to infinity also. Okay? So that's how we solve this one. Remember, so to recap, to take the limit as this guy as it goes to infinity, we first take the natural log of a sub n, which is this guy. Remember properties of logs, so we can pull the exponent out. We took the limit of this guy. We can rewrite it as this. And then we use L'Hopital's rule. So let me put LH there. L'Hopital's rule. And then we simplified to here. And then we took the limits. That would be going to positive infinity. So this was the natural log of a sub n. So we just exponentiate our answer to get the limit of this guy going to infinity, which is also infinity. Okay, so that's how we solve that. Let's move on. 3b. We have a sub n is square root of n squared plus 1 over n. Okay, so limit as n goes to infinity. Okay, this professor actually has quite bad notation for these. But anyway, let me not look at that and let me solve it myself. What was I doing? Okay, we want to take the limit as n goes to infinity of a sub n, which is this guy. How do we do this limit? Okay, so we can, if we just plug in infinity, that'll just be infinity over infinity, which is indeterminate. So we could use L'Hopital's rule. We can use another technique. Maybe let's just use L'Hopital's rule. So that would just be 2n over 2 root 2 n squared plus 1 all over 1. So derivative of the bottom, derivative of n is just 1. Derivative of the top, the square is 1 over 2 root of n squared plus 1 times derivative inside, which is 2n. Okay? These 2's would cancel. Oh, forgot my limit notation. Don't forget that. Limit as n goes to infinity. So we're left with n over square root of n squared plus 1. Okay, so what do we do here? It's still infinity over infinity. Can we do L'Hopital's rule again? Would that help? I feel like it would no longer help, but let's just try it. I'm solving this live with you. This is just 1 by L'Hopital's rule, and this is 1 over 2 root n squared plus 1 times another 2n, like that. Yeah, so this is not going to work. Okay, so let's abandon this method. Let's try the other way. Limit as n goes to infinity. We know that this is a horizontal asymptote that we're trying to find. Remember the technique to do that in Math 2a? Limit as n goes to infinity. We can factor out n squared. So that'll just be 1 plus 1 over n squared all over n. Okay? Because, so square root of n squared we can simplify as plus or minus n. We're going to, as n goes to infinity, so we can take it as plus n. So just be n times 1 plus 1 over n squared all over n. Okay? These would cancel. Now limit as n goes to infinity of this guy, this is easy, that would just be 0. So we're left with the square root of 1, which is 1. That converges to 1, this sequence. Okay, let's move on. Okay. 1c, we have a sub n is 1 over square root of n plus 1 minus square root of n. Okay. So limit as n goes to infinity of a sub n. Remember how we solve this type of limit? Well, first of all, if n goes to infinity, well, we have an infinity minus infinity. That's undeterminate, so that's why. Infinity minus infinity, okay? So how we solve this, we can use the conjugate. Remember how we do that? That's square root n plus 1 plus root n over square root of n plus 1 minus root n. That's the original. The conjugate is square root of n plus 1 plus square root of n. It's very messy, sorry. And then don't forget limit notation. Okay? This is limit as n goes to infinity of square root of n plus 1 plus square root n. The bottom, if we FOIL that, will be n plus 1 minus n. Okay? So these would cancel. We get limit as n goes to infinity of square root n plus 1 plus square root of n. This now is infinity plus infinity, so we get it diverges to positive infinity. Okay? So next one, not 1, we're on 3, right? 3D, we have a sub n is e to the sine n over n. Okay? So how do we solve this? Limit as n goes to infinity, a sub n. Well, remember we can take by properties of the limits, e to the limit as n goes to infinity of sine n over n. That's valid. Okay, we can do that. How do we take this limit? Remember the squeeze theorem? We know that sine is between minus 1 and 1. We multiply everywhere by 1 over n. So make it look like this in the middle. So we know that limit as n goes to infinity minus 1 over n, that's 0. And limit as n goes to infinity of 1 over n, that's also 0. So by squeeze theorem, limit as n goes to infinity, sine n over n is also equal to 0. Okay? So you have to write this by squeeze theorem. Okay, so we found this limit. This is just e to 0, which is 1. So it converges to 1. Okay, next, I believe this is the last problem. Yes, okay. A sub n is minus 1 to the n over 4n plus 2 to the 1/3 power. Okay? Remember, for this, because it has alternating sign, we can first take the limit as n goes to infinity of absolute value a sub n. Okay? This guy is simply, because we took the absolute value, this alternating sign would go away. We are left with 1 over 4n plus 2 to the 3 to the 1/3 power, sorry, that's messy. This is a 1/3. Okay? So when we do this, we would get 1 over infinity, which is 0. Okay? So therefore, we can say therefore, limit as n goes to infinity of a sub n is also equal to 0. Okay? So you had to show that we took the absolute value of a n. Found that limit, therefore, this limit is also 0, okay? So that was this midterm. It was not too difficult. There's a little bit more conceptual questions, like the integration by parts question, and then that convergence of the improper integral for what value of p. That was a little bit more conceptual, but not too bad at all, okay? So as always, if you have any questions, feel free to leave it in the comments. And if this video has helped you in any way, please hit that like button and please subscribe to the channel to see more videos like this.